Allegiance, where you have to say, the only thing you can say is words from the Pledge of Allegiance in order. Are you there? I. Are you interested in this Pledge Allegiance? But they'll figure that one out fairly quickly, right? Or you could, there's more complex ones. My sister used to pretend that my mom was a patient in a mental institution. And is Mrs. Pearson there, right? Oh, yes, she's here. Can I speak to her? Oh, I think she could talk to people today. I think she's okay. She's having a very good day. Now, don't mention, don't mention hunting accidents. And, she was just, and my mom would be just convulsed, so all she could say was like, My sister would be like, Mrs. Pearson, calm down. Yeah, types of waves. My dad's friend used to just go off. He was an extemporaneous actor, and so if they offered him dance lessons, he'd be like, he'd start crying. He'd say, I was paralyzed last year in an accident. And, yeah, this is not very funny. Okay, so this is a crazy thing, right? If you've got the Earth is, here's a trick question, right? The Earth is mostly solid, mostly liquid. Does anybody know the answer?
Wait, what?
The Earth is A, mostly solid, B, mostly liquid. Yeah, it's probably, since I'm asking the question, it's probably the thing you wouldn't expect, and that is, it's mostly liquid. The proportion of the Earth that is solid, solidified rock, is to the whole Earth as the shell of an egg is to the egg. I'm hungry, thanks. I know. And if you take a basketball-sized Earth and add a coat of varnish to it, that's about the size of the atmosphere, so it's pretty fragile. Here we have it, right? So basically, we are on top of, like, sort of, imagine a pot of soup, with like a little scum on top of it, right? Okay, and that pot is boiling. There's convection currents in the soup, and so the scum is sort of getting created in certain places and sort of brought down into the soup in other places, right? That's basically what it is, right? But anyway, imagine that you have an earthquake at A and you've got a seismic station at B. Well, the P wave can just travel right through the liquid core of the Earth. This is how they know the core of the Earth is liquid, right? And the creamy, liquidy filling of the Earth, right? And the S wave has to travel around the Earth in kind of a very badly formed auto shape from PowerPoint, like that, right? And so the S waves will arrive at some point later. Yeah, that's kind of cool. Is that cool? That's kind of cool. Earth is like an egg. It's like an egg. And then, of course, they transport energy. This is how the Earth is warmed. The sun warms the Earth. When I speak in a microphone, the sound waves move the air moves. And in fact, this thing right here, by the way, if I hook this to the microphone input of something, this actually is a microphone. All speakers act like microphones. And so when I talk, I'm actually moving this little speaker cone in and out with my voice, and that's actually making an electric signal right now. Next year we'll hook this up to a oscilloscope, and you'll see that speakers actually work that way, right? So we're turning actually sound energy into electrical energy. Obviously, earthquakes transport a lot of energy, right? A microwave oven, how does it cook food?
Gamma.
Yeah, gamma rays. Well, not so much, right? They actually originally thought, the guy who discovered microwaves, the microwave thing that he was building melted a chocolate bar in his pocket. And so the original plan was to use microwaves to heat rooms, right? And it's clever. You heat the people in the room, but you don't heat the air. Except for it ruins your brain thing. It was a good idea, Like cooks your brain, right? Yeah.
How do speakers amplify the sound? How do they?
They don't really amplify it, but they're actually about 3% efficient. So it's like if you send 100 watts of electrical energy in, right, you get about 3 watts of sound power. But 3 watts of sound power is pretty killer. That's like the loudest thumper car you've ever heard with it. Just the windows shut and it rolled up, right? So the way they create sound is they just move in and out like a drum head. They're compressing the air and rarefying the air. right? I'll show you the solar concentrator.
Things like all the mirrors.
The solar, well, yeah, I showed you my sister. My sister worked at one that was like many stories tall. This is Keenan did this for his. There's a Fresnel lens. We're concentrating the sun's light.
What it does is concentrate the sunlight.
Your dad, the teacher, right? He's like blah 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 blah.
And here you can see it's hot enough to catch this box on fire.
He's got sunglasses on because that really hurts your eyes. It's so bright. I like the audio. Like,
here's the Fresnel lens from the front side. Basically a very large lens that's been collapsed like a folding cup.
I made that analogy.
Okay, our next device is a...
So this is like my sister worked at Four Solaire, the solar furnace in the Pyrenees. And the bigger that is, obviously, the more stuff it's concentrating, right?
The focal point. When he hits the right spot, it'll just burst into flame like that.
Hard to see that it's flaming, but there it is. My sister, when she was at University of Minnesota, they had one that was like 8 feet tall.
There's the focal point.
And it was made out of many, many little mirrors. Look at this. See how the sun concentrates?
Kind of interesting. I think it's a cone.
That's kind of cool. So they built a concentrator. This is what she did her PhD research on, right? They built a concentrator, and it was like 10 feet tall. And rather than have just like one mirror, they had like 400 mirrors about this big, and they were all on little gimbal mounts so they could focus them. And then they just took a laser beam and made it so that when a light came in straight in, it would concentrate it onto one point, like that, individually, right? And they got it all set up, and then this thing just sat there, and then there was a big flat mirror that would reflect the sun into it and track the sun and keep it pointed into there, right? So it was like this. Right? Here was this thing, there were garage doors here. Here was this parabolic mirror, right? Out here was a heliostat, so the sun would come in here and reflect in there, only it would actually come in straight, right? It would come in exactly horizontal, right? And then this was a concentrator. There was a little thing there, and you could do, it would all focus the sun's rays on this thing, right? Well, no, okay. Yeah, you would know that, right? It would just singe your ear off, right? The first thing they did when they set it up was they put a hot dog in the focal point. Yeah? Well, if you concentrate, 100 square feet of solar energy onto a hot dog, you know what it does? It explodes. And it coats 400 mirrors with hot dog grease. And when you clean the grease off of 400 mirrors that have, right, that's kind of hard to do, right? They all need to be re-aimed, don't they? Isn't that sad? She did not do that, but that was a story. They had sheets of half-inch steel that they melted with this thing. I was like, wow, that's pretty good, right? Okay. This is exactly the way Four Solaire works in France, only this thing is like 6 stories tall, 10 stories tall, right? Yeah. That's a solar furnace in the Pyrenees. It's just ginormous. Yeah. The place that they concentrate the light on is about the size of this room, and the thing is like got to be 100 feet tall. Yeah.
Would that be like more to capture energy like that? Would that be like more efficient than like solar panels?
Well, it generates high temperature, so basically it's kind of a novelty. But her notion was that she could maybe make aluminum with it, right? Or her PhD research was to get methane out of cellulose or something like that, right? So to just use the high temperature to do something. We could, I think we'd probably find a picture of. There it is. There it is. That's a very small picture. Make it big. That's a thumbnail. There you go. That's pretty big, isn't it? And these things, again, these are multiple panels, right? This is the part that's blocked by the concentrator, which is behind the trees here.